In this video, we're going to kind of move into a kind of an applications phase. We want to talk about something referred to as the discounted cash flow techniques, more commonly known as the time value of money. This is a very important aspect of making decisions. All of our decisions are based on things that you think are going to happen in the future. I think in 5 years, I need to buy a new car. I'm going to need $25,000 in 5 years. How can I save money, maybe on a monthly basis, to get that amount? That is a time value question. So let's work our way down through some of these questions. We're going to talk about capital budgeting. Capital budgeting is corporate decision making. What is the value today of a project that we want to do? So if you think, let's say we're going to build a plant across the river. What benefit does that bring the company in today's dollars? So we're going to have to project cash flows in the future. And we're going to have a way to compare those future cash flows to today's price. But today's dollars and future dollars don't buy the same thing. So discounted cash flow, as they mentioned here, it's the backbone of finance. It's used to evaluate cash flow streams when they're beyond the current year. Why are they important? Again, most of the time we're talking about things over time. The adjustments that we make for the time value of money are critical, right? They can really impact our decision making. And they allow for a measurement of shareholder wealth or value creation. There's a 3-step process to establishing or calculating capital budgeting techniques. We need to estimate relative cash flows. We will talk about this maybe in a later video. You need to calculate a figure of merit for the investment. Well, what does merit mean? Merit is just an idea, right? Or a concept that looks at value or benefit. So we have to have some techniques that will help us calculate this. Sometimes we'll be looking at dollars, and sometimes we'll be looking at just base numbers. Sometimes we'll be looking at percentages. And in the end, we need to compare that merit number, that value, that technique answer, if you will, to some form of criterion. So how do you establish cash flows? We need to forecast income statements and balance sheets that are going to be created by some project. So this is really a very important aspect of investing and corporate decision making, and it's very difficult. We're going to use many parts of the company. We're going to use marketing. We're going to use production, right? There's lots of effort going to be placed in trying to estimate what we think is going to happen in the future. So some of the things that talks about that we have to estimate here: depreciation, cost of finance, excuse me, working capital needs, any shared resources, any excess capacity. We have to look at how it affects other opportunities that we might have. So there are lots of things that we need to evaluate when we're looking at projecting cash flows. So we're going to come back, as it says, in later videos, we'll talk about this cash flow or this idea of investing. But we're going to start off kind of simply. Let's just start off, assume that we already have those numbers. So we have a project. we're going to spend $40 on this project, and each year for the next 9 years, it's going to pay us $7.50. On the 10th year, we're going to receive $17. Now, this timeline can be very important for some more complicated problems, but this is the way a typical project will look. Now, a couple things to keep in mind. This $40 is a negative value, right? Because we're going to spend $40. You can see it's negative up here. And it happens at time 0. Time 0 is today. And obviously the cash flows then occur every year for 9 years of $7.50 and then $17 at the end. That is a typical kind of a project. So one of the first techniques that we can talk about is something called the payback period. The payback period is the amount of time it takes to get your money back. If the cash flows are even, unequal, then you just need to divide the cost by the cash flows. So as you see here, if you divide 40 by 7.5, it'll take roughly 5.33 years, 5 1/3 years, for us to get our money back. The accounting rate of return is another technique, not actually used all that frequently by larger corporations, but essentially what you do is you find the average cash flow. So we got 7.5 times 9, and we got the 17th in year 10. So that is the sum of all the cash flows, divided by the 10 periods, then divide that whole thing by 40. So the accounting rate of return, again, is 21%. What all of these techniques have is some kind of a rule to follow. So for this first payback period, what if we said we won't do any projects unless we get our money back in 4 years? So if that's the rule for payback, we don't get our money back for 5 1/3. So since it is more than the benchmark that we set, then the project would be unacceptable using the payback period. The accounting rate of return, again, is a percentage. So again, if we said, look, we're not going to do any projects unless we can at least get 15%. So obviously 21 is greater than 15. That means that we would, at least using the accounting rate of return, this project would be acceptable. Now what we'll find is we're going to talk about several different techniques. They all will give us maybe different answers, right? Some will say to accept the project and move forward. Others will say reject the project and go find something else to do. The problems with these techniques, and there are several of them, but the primary project challenge is it doesn't use the time value of money. We're just using the gross number of the cash flows. And time value of money, as we'll see in some later videos, is very important to understand the actual value, because we can invest money. And if we want to apply opportunity costs, we have to apply the appropriate returns that we could get from alternate types of investing. In addition, they also don't use all of the cash flows all of the time, right? So again, this is part of the challenges with these two, what many people refer to as being unsophisticated techniques. They're unsophisticated because they don't use the time value of money. So let's spend a couple of minutes talking about this time value of money. First of all, why does the value of dollars change? Primarily 3 things. Inflation is the primary culprit here. Inflation beats up the dollar. So future dollars will not buy as much as current dollars. So since they're still just dollars, right? George Washington is in all $1 bills, but those $1 bills don't buy the same amount of stuff. Certainly, then uncertainty and opportunity costs are also going to have an impact on the time value of money. So if you look at time value, we have just a few variables. PV0 is the present value or the beginning amount, present value. R is the interest rate, typically stated as I divided by Y. That's interest rate per year. FV subscript N is the future value or the ending amount that occurred over N periods. N is the years. A is sometimes referred to as the annuity or the payment. PVA is the present value of an annuity. FVA is the future value of an annuity. PVA could be looked on as a loan question. FVA can be looked at like a retirement question. And finally, we have variable M, and M is also sometimes shown as P divided by Y, which is periods per year. So how does this work? The process can be looked at as either being something called compounding or something called discounting. Compounding is how money grows. It's when interest earns interest. Now, there are several ways we can calculate these formulas. You can calculate it using the actual formula. So to find the present value at sometime N, you need to know the present value. You multiply that by 1 plus R divided by M. R is the interest per year. M is the periods per year. So if this is a 12% return and we have monthly payments, 12 divided by 12, that would be 0.01. Then you take that in parentheses, you take that to the N times M. So this takes into account what we refer to as frequency. How many times per year do you calculate interest? Now, another way to calculate future value is to use Excel. So equals FV, that's the formula in Excel. And when you type that in the cell, you will see these phrases come up. What is the rate? Well, the rate, we have to be very careful. This is rates per period. So this should really be the rate divided by M. So let's see if we can check. I don't think I can change it. I think it's a picture. The number of periods is this number here, N times M. How many periods are there in the investment's life? It's a 5-year investment, 12 payments per year, because it's monthly. That makes 60. The payment is next. The payment will always be entered as a negative number because it designates it as an outflow. Excuse me. The payment could be positive or negative depending on the kind of problem you're talking about. If you're talking about future value, the payment is an investment. So in this case, it would be negative. Present value indicates a number that you're investing today. And again, since it's an investment today, you would put that in as a negative number. Now, most of our examples are going to be a little bit simpler. So this type tells us whether the investments are made in the beginning of the year or whether they're made at the end of the year. The calculators and computers that we use all assume that the type equals 0, so that the cash flows actually occur at the end of the year. And that's the way this formula also assumes those end of the period cash flows. So if you wanted to do this investment for 2 years, again, how do you do that? It's you invested $1, it earned 10% the first year, and it earned another 10% the next year. So again, multiplying those out, we would end up with $1.21. If you work that in reverse and calculate present value, you take that future value and you divide it by, here's our formula, 1 plus r to the nth. But remember, r is the rate per period, and n times n is the total numbers of periods. So you can do that formula. And these formulas aren't terribly difficult, although they do require a calculator that will do exponents. The Excel formula for this is the same basic formula, except we have present values, what you're solving for. Here's the rate per period, total number of periods, payment. Now, typically the payment here is going to be 0, right? Because in this case, we're not making a payment, we're trying to solve for that. For future value, right, that's going to be a positive number because it's a number we assume we're going to get in the future. And of course, type, again, will almost always be 0. So let's look at this example. How can we do this example with formulas? So your boss is going to pay you $1,000, or excuse me, promises you a bonus of $10,000 in 3 years. If your discount rate is 6%, what is the present value of this bonus? So if we look at the formula, present value equals, we have the cash flow divided by 1 plus R divided by M, that in parentheses, to the N times M. Now in this case, we have 3 years, and that's all you know. So the M's are equal to 1. So this would be the cash flow divided by 1.06 to the third power. So the cash flow was what? $10,000. So if you do that calculation, it comes up to roughly $8,396. The other problem is a future value question. How much will you have in an account in 10 years if you invest $5,000 today and it pays 3% annually? Again, you can calculate the formula, right? The formula is future value equals present value times 1 plus, now this is just 1 year, so we're just going to do R. Now let's go ahead and do it. R divided by M. This is to the N times M. Again, M equals 1. So again, this is just what? $5,000 times 1.03 to the 10th power. If you do that math, it's roughly $6,719 and some pennies. So that's how we do this formula simply, right, with the formulas. As we move forward, I'm going to introduce the Excel opportunity, right? So we'll use some Excel numbers and formulas to answer some of our questions and some of the problems. So I look forward to seeing you in the next video.